Good morning and welcome. Welcome from the great state of Washington, from the beautiful Microsoft campus, newly renovated Microsoft Virtual Academy Studios here. My name is Jerry Nixon and you are watching the Jumpstart for exam 70483, C# Fundamentals.
Good memory.
Excellent, yes. I'm good with numbers. My name's Jerry Nixon. I'm one of your co-hosts today. I'm here with my friend and colleague Darren May. Good morning, Darren.
Good morning, Jerry. How are you?
That interesting and strange way that you talk is interesting to me. Okay, so I'm from Colorado. Darren also is from Colorado. Darren, you must be a native from Colorado.
I am, born and bred.
Yeah.
Highlands Ranch.
Also from Colorado, I'm a developer evangelist here with Microsoft. I tend to focus on Windows 8 and Windows Phone, XAML, and I've been friends with C# now for about 700 years, Darren. I'm not good with numbers, I told you that already.
Yeah, 699?
If you don't count college, yeah, I guess that's right.
That's probably true.
Now that you say it.
Yeah.
And Darren, tell me a little bit about who you are for a second.
So my name's Darren May, as we mentioned. I am president and CEO and co-founder of a company called Crank211. We based out of Denver, Colorado, and we do a number of rich user experience applications and so on. Much like you, I've been using C# since year dot. Pretty much the early beta of C# and Visual Studio 2002, I guess it was. So that's a little bit of my background.
Back in the aughts.
Back in the aughts, back in the early days.
I talked to a guy, you referred to it as the Audis. The naughties, he finally said it.
Okay.
It was crazy.
Awesome.
So today, let's talk about some of the expectations that we want everybody to know, some of the level setting, and let's kind of move through that. So I'm Jerry Nixon. I do want to say that if you do want to find us online, I'll start with myself. I'm at jerrynixon.com. I blog with abandon, Darren. Just
you do.
It's crazy. And if you like the Twitters, then I am at Jerry Nixon, and you can find me there as well. Darren, where can we find out about Crank211?
Funnily enough, at next slide, www.crank211.com is where we are situated on the interwebs, and basically you can find out kind of what we do there.
Excellent, excellent. Crank211 is a funny name. Where's something like that come from?
Have you ever seen the movie Spinal Tap?
A movie?
Yeah, there's a movie. It's a rockumentary, I believe they call it. And there's a particular scene where one of the members of the band is going through his guitar collection and he comes across this speaker. He says, "This speaker's special." And the interviewer's going, "Well, why is this speaker special?"
It's loud.
It's loud. It goes to 11.
Well, I thought they only go to 10.
No, this one goes to 11.
It's brilliant. All right.
Okay, moving on.
So today is going to be a jam-packed day. This is the agenda that we had to fit in a single slide, kind of like the fact that we're taking a 5-day course and fitting it into a single day. This agenda doesn't really give much justice to all the things we'll be covering today, just like this course doesn't really give much justice to the 5-day course that will be covering a great deal more content. So this is a jump start. It's intended for developers who either do or don't know C# at a level where they're ready to take the exam, or where they do know the exam and they just want to have a little bit of confidence and reminders kind of given to them as well. It'll be a good course. We'll start with some of the basics, and the first hour especially will be very little Visual Studio. We're going to talk about the fundamentals of object-oriented programming and some of the coolness that you may have forgotten is behind C# this whole time. Pretty neat. As far as prerequisites, if you are a developer and C# and you don't know how to spell C#, this course is going to be rough.
This course is going to be rough because we're going to introduce some of the foundational concepts. We're going to go through some of the assumptions around the language and so on, but we don't have the time to cover every aspect of the syntax. We don't have the time to really do a deep dive in every area. So some things we'll focus on because they are of more emphasis perhaps in passing the certification. Other things we'll just mention in passing and we'll talk about as we do the demos.
I think it's fair to share right now that this was a painful process because surely, that's talking to you.
Yeah, don't call me Shirley.
C# is not a shallow topic. And to cover it in one day, there's lots of things we just simply cannot talk about. And so in order to do that, We had to cut quite a few things out. And for us, who really love the language and just love helping developers, to be able to cut things out it was just a painful process to do.
I felt like I was a movie director. I was cutting out my favorite scenes. So that kind of speaks to some of the source code that we actually have to support here.
And a little bit of our own vanity to think about it like that.
Exactly.
Yeah, no doubt.
We have a lot of source code. There'll be links on where you can go and download that, so if you want to follow along with us. There is many, many more demos than we will actually incorporate during the day. And so if you go through and have a look at the project, you can see many snippets of ideas that we've had around how you can implement certain features and so on and so forth. So that's out there.
And if you're wondering which ones we cut out and didn't fully bake into this course, those would be the projects that are empty. The name is there. Yeah, those are the ones that we look for contributors to be able to fill those in if you're excited about it. So Microsoft Virtual Academy, just go through some housekeeping. Hopefully everybody knows where their own bathrooms are and things like that. We'll go in a series of modules with some breaks in between each one of them. There'll be 50-minute modules with a 10-minute break at the end of each. We'll break for lunch. Microsoft Virtual Academy, so both, not just for developers, also for IT pros as well. A lot of courses that you can take that have already been recorded, many in the hopper that are coming to you as well. Over 1 million registered users. That's pretty impressive.
It's a lot of people.
That M might mean, I don't know, maybe it doesn't mean million. Maybe it means 1,000. Let's go with 1 million. There's 1 million registered. Did you see that note?
I did.
It's beautiful.
The demo gods have paid us a visit
Required
already.
restart. That is a curse in the morning. That's wonderful.
Thanks, MSIT.
That's great. Over 1 million registered users with relevant training and really a fantastic catalog that you can pick from now. Not that expensive to take courses on Microsoft Virtual Academy.
And
right?
damn free to listen to us. So enjoy.
Free all the way around. All right, so earn while you learn. You can get MVA points, and with those points, do you know what you can get?
Point to win prizes?
You know what? You can do a lot with those points. If you'd like to learn more about it, you can go to MicrosoftVirtualAcademy.com, where it's all sitting there for you. If you want to get credit for this course, don't forget there's a code that you can use that expires March 29th. And you can get extra points. That's pretty cool. I wonder if they're like Xbox points.
I don't know, Derek.
I'll bet they are. I'll bet they are. I'll bet they're not.
Yep.
Now that I'm really thinking about it. I wonder if they're like big
Why don't we
points.
move on?
Yeah. Let's focus on what we do know to talk about more. All right. So Darren had alluded to the fact that we have quite a bit of source code that you can use to follow along with us or to do your own research and dig into. That is all up on CodePlex. There's a CodePlex project called XAML Show where you can... XAML Show is the beginning of showing off all the features of XAML in Windows 8 and eventually Windows Phone as well. But it's also the place where you can go download these samples. It's right there on the first page. It's under Microsoft Virtual Academy where you can download it. XAML.codeplex.com, and it is a wealth of information.
It's a great place to go, as you say.
Yeah.
And it's going to get more rounded out as we move through.
Perfect. All right, listen, the first module is important. I don't want to take away from it anymore. You have it up and ready to go?
I have it up and ready to go.
All right, let's hit it and really start nailing this thing.
Okay, so the first module is really going to be an introduction into object-oriented programming, managed languages in C#.
Is it pronounced oop?
Not by me, maybe by you. So, the module agenda will initially hit, as I mentioned, object-oriented programming, just define those key concepts. Then we'll introduce the concept of managed languages and basically talk about those structures, what managed languages provide for us. Then we'll talk about why C# is a good choice for object-oriented programming, and then we'll basically wrap up. So, let's dive straight into object-oriented programming. So, what is an object?
An object is the foundational piece of object-oriented programming.
Okay, so when we're talking about foundational piece, what does that really mean? Well, fundamentally, an object is modeling a concept. It's an idea. It's something that represents an interaction, perhaps in the real world, perhaps in a problem domain. So there's usually three things that an object has. It usually is something. For example, it may be a customer. An object usually has data, so the customer's first name, their last name, perhaps their address, perhaps a customer ID. And an object usually performs actions, so you can make perhaps a customer preferred, or you can change the customer's first name and things like that. So we're modeling a concept.
So an object, just to simplify it down, is really just a thing.
It is a thing. And to define a thing, we have to talk about its characteristics.
We do. And at design time, or at when the developer is developing, they don't have the data yet, but it's going to be that container for the data that they'll have at runtime.
Absolutely.
Okay. Makes sense to me.
So what is object-oriented programming? Well, it kind of makes sense now we've introduced the concept of an object. It's effectively programming that's designed around the manipulation of objects. To be object-oriented, it has to be focused on objects, and it has to have certain properties and exhibit certain behaviors. This means the language generally includes 3 key properties: encapsulation, inheritance, and polymorphism.
If we get paid by the syllable, we're going to hit it on this one.
Exactly.
Yeah.
So let's talk about the idea of what encapsulation is.
Okay. Encapsulation, if you were to think about all the code that you're going to write, encapsulation is putting a wall around your code. Is that a good way to think about it?
It is.
And it's definitely meant to say people on the outside of the wall, I'll tell you how I do it, but I don't want you to look at it and get confused by it, start thinking about it, get distracted by it. I can take it and bring it all in here, and all you interact with me through the windows and the doors.
Yeah, it's effectively establishing a contract, a commitment of behavior, but obscuring the implementation details of that behavior, so that you know that a customer has a first name, but you don't care how that first name is actually stored. You don't care how you actually interact with that first name. You just know that you can pull it out through that first name contract.
Yeah. First name, property.
Exactly.
And here we go on all the pieces. Encapsulation also allows you to take the code that you write and present it out to another audience as well. I could encapsulate my code and not worry about, say, intellectual property as well. I could make it so that I could give you my code because it's encapsulated. One, I know that you won't use it wrong. Well, I mean, you know what I mean. And the second one is I can have it all inside those walls and trust that my code can be protected through one of the mechanisms that I choose. Otherwise, my other option would just be to give you the source, and that is just not going to be good enough.
Okay, so the next feature of object-oriented programming is inheritance.
Ah, yes, inheritance.
So inheritance is fundamentally about the idea of code reuse. You create behaviors, and you can then have objects that inherit from other objects and obtain those behaviors through that inheritance chain.
Yeah, where the default definition in somebody's mind for inheritance may be the money they get from their parents, right? What this is more like is the funny nose they get from their parents, genetic inheritance, right? And whatever it is that your parents might have, you actually inherit their qualities. That's the same way with objects that inherit from other objects. You inherit their qualities as well, especially when we get to it, properties and methods and things like that, the signatures inside those objects.
Absolutely. And then we come to the final one, polymorphism, which everybody always loves to say.
Polymorphism.
Polymorphism.
I'm a monomorphist myself.
Okay. So polymorphism comes from the Greek, which is to have many forms.
Wow.
Shampoo.
Shampoo.
And so, in effect, what polymorphism is talking about, it kind of plays into the inheritance aspect as well, is if an object is inheriting from another object, then the object to which we're initially referring can be interacted with as if it was the object from which it inherited. Now that sounds really crazy to talk about, and so we'll be demonstrating it later on, but fundamentally that's what it means. You have the ability for an object to appear to be different shapes, as if they were different types, based upon how they're inherited.
If you saw the Transformers movie, you probably saw polymorphism constantly.
Are we going to do a Bugby meme now?
All right, polymorphism. Fantastic. Objects can become other objects, in a sense, other types.
Okay.
All right. Now, at its foundation, when we're going to be talking about C#, not just object-oriented programming, one of the things is managed languages, managed runtimes. It's an important topic. Let's talk about just what is a managed language.
Absolutely. So managed languages are fundamentally depend upon the services that are provided by a runtime. So in this situation, we're talking about C#. C# is one of many languages that compile into managed code.
C# is one of a few languages, surely, many.
There are many, many. There's COBOL, there's VB.
Yeah.
There is F# compiles into a managed language. Yeah. There are many, many different implementations. Obviously, you've got managed C++.
Well done. So, a managed language cannot exist unless it's enabled by a managed runtime. That part we know.
Absolutely.
Keep going. You were doing great.
So, the managed runtime in .NET is called the Common Language Runtime, and it provides a number of core services that the managed languages need to be able to perform. Such services include automatic memory management, but we're going to go into detail. But really it solves one of the key problems of using unmanaged languages such as earlier versions of C++ and so on, where the developer was responsible for very fine-grained memory management, such as allocating memory and remembering to release it when it was finished. That was a cause of major issues around memory leaks and so on and so forth.
And that's a very repetitive task, too. This is great.
Yeah, it's a lot of template code that you have to keep reusing, and that's not.
And it's the sort of thing that developers often got wrong because it is actually complex. And so what would happen is they would write an application that did all of the things that was in the domain of their application, and then they would get some of the boilerplate stuff wrong and make it look as if it was unstable. A runtime enables all of that boilerplate for you. It's really around, not just around getting it right, but it's also around productivity for the developer as well, so they don't have to build all of that. Just leverage what's already there inside the runtime. Certainly a runtime does more than that. There's also security elements, and there's also portability, right? That's also
portability. There. You've got the macro level exception handling. The Common Runtime provides that service. And there's also standard types, so standard ways of interacting with data. So we'll talk a little bit about types in a second.
All right. How about now?
Sounds like a great plan. It's almost as if this was a plan.
I do not want to talk about non-standard types.
Well, that's a good thing.
Okay, let's talk
We'll get to those later.
About standard types.
Exactly. So a type is a foundational building block of any application that's built in a managed language. The type really defines what an object is. It has metadata about that type. It talks about or has data around the memory allocation that's necessary to store that type. It has metadata that talks about what properties are exposed by the type, what methods or functions that type implements, what its level of access is, and so on and so forth.
So if I see an object and I want to know about that object, I need to interrogate its type. Type's a funny word because type defines what type it is.
Yeah.
I mean, it's tricky. But if I want to know about an object and what all is inside it and what all it's supposed to do and what all it says it can accomplish, I use its type. Now, I don't do that very often, but the compiler does. Yep. If the compiler wants to understand this object that I'm invoking, then it is using its type and all of the metadata inside that type that describes the object so that it knows what to do with it and what not to do with it, which is probably the most important part.
Exactly. And that type metadata really helps you in your development environment when you're inside Visual Studio, because that is what helps you use things such as IntelliSense, get the compile time checking. The IDE brings that back. Excellent. So, one of the other advantages of standard types is that all types in the managed environment inherit from a common base, which is, funnily enough, called object.
Every object ultimately inherits from object.
Exactly.
And you don't see that in the syntax. Later we'll see how to inherit from something, and it doesn't say from object.
Exactly.
Everything is from object.
It's implicit, and it occurs for you automatically.
What about the cat object? It comes from object?
It absolutely comes from object.
Integer?
Integer, absolutely.
Everything comes from object.
Everything. That's really what it means when it says common base, Jerry.
Yeah, I really get it. All right.
Awesome.
So explain it to me. I come from object. What do I get from that?
So there are about 4 methods that object implements. One of them is toString, so that every time you refer to an instance of an object, every object has a toString method. Now, the default implementation of toString happens to print out the fully qualified type name, which we'll get to a little bit later on, which may or may not be particularly useful, but at least there is a standard implementation. One of the great features of object-oriented programming, and C# in particular, is you can give a new implementation of toString that may be specific to the object that you're using and to the scenarios in which it's being used. And so, that's some of the power of object orientation.
And back to inheritance, one of our big words, right, is because of inheritance, object implements toString, but that means because everything ultimately inherits from object, everything has toString, and it just keeps on going. You can kind of really see inheritance being driven there too, where whatever the parent has, the children have by default. So there's not really much implementation in object. Thank goodness, otherwise we'd have IntelliSense would be clouded with all kinds of things.
Absolutely, and also, you want it to be a template for sort of basic default behavior. You don't want to make assumptions around everything that all the objects should have. And so I think the things that it's got, such as the hash code and the default equality checking and those kind of things, make sense from that core object perspective. But it leaves the rest of the implementation up to you and the domain in which you're modeling.
So we can't do without types. And we're talking about the managed runtime, managed languages. Types are fundamentally at its base. All types are created equally?
Absolutely.
All types are the same?
No, they're not. We have 3 categories of types.
Interesting.
So the first type is a value type. Now, the interesting thing about value types is they basically point to the data directly. These are normally your low-level types, such as an int, a boolean, a double, and so on and so forth. They represent very much a very narrow definition of data.
A simple piece of data.
Very simple piece of data.
And I'll just jump in to say, and one of the reasons it's so lightweight or so simple is because they're so common. And if you started having all of these heavy things constantly, we'd have memory issues quickly.
Yes, exactly. I mean, it's an optimization characteristic. One of the interesting things about unmanaged languages, or managed languages rather, C# and so on and so forth, is it's constantly balancing usability, programmer productivity, and performance. And so there are these constant tensions in the language that keep it really true to a general purpose language that can solve most things very, very well. So we mentioned value types. The next type is reference types.
Reference types.
So reference types really speak to object instances. And the interesting thing about a reference type is the value is stored is a pointer to where the object data is actually stored. Okay? So a value type points directly to the data. A reference type points to a location where the object data is stored.
Yes.
Okay? So that's a key difference, and we'll come back to that. The third category...
It's almost like an index card in the library telling you where the book is.
Exactly.
Rather than the book itself, which is the value type.
Exactly. Pointer types are the final type, and these are only available in unsafe code. We're not really going to talk much about unsafe code, but fundamentally you have the ability in C# to mark a block of code as unsafe. And what this means is it is accessing memory directly as opposed to using the abstractions that the C# and managed libraries provide.
Those abstractions give a lot of safety for developers, a lot of safety also for the user of the system, so they can trust the application that's running. Fundamentally, we're talking about the managed language, managed runtime. It is a safe environment, and it is safe code. But at the same time, we've given the permission or the capability to developers to write unsafe, dangerous, awful code. Right? That's the short of it.
Fundamentally, it's there for those high performance requirements where you need to manipulate memory directly. And so, as I say, we don't really touch on any of those scenarios within this session, but be aware it's there, and it's useful sometimes perhaps when you want to manipulate bitmap data and so on.
There may be a COM jumpstart coming, and then they can touch on unsafe code all day long. Nice.
Okay. So the next section.
So wait. We're talking about managed languages.
Whoa.
We're talking about managed runtimes. We're talking about types and how important they are inside those runtimes. Now, we haven't talked much about C#, right? Here we go. How does C# play into all this? What's the point of C#?
Well, C# was basically developed to be a general purpose programming language. It was designed to obviously be object oriented. It's the lead architect for it, Anders Kjellbergs, he invented Turbo Pascal and was the lead architect for Delphi.
I was a Turbo Pascal Delphi.
That's how you guys say it.
Yeah, y'all.
Delphi.
That's how weans say it that way. I was a developer for that in high school.
Yeah.
That was my first programming language.
Yeah. Was that on a wax tablet? Anyway.
Cut the slide.
In case you hadn't noticed, we do intend to have fun. Hope you guys
When's
are
that going to
too.
start?
Exactly. Okay, so C#. It's pronounced C#, and that's why I keep saying C#. It's interesting we have that
It
on the
looks
slide.
like C pound is why.
That's right. Or we would say in England C#. Interesting.
Yeah. Everything is hash in England.
Oh, I say. Do you? So, as we've mentioned many times, general purpose language, object-oriented, focused on dev productivity. We're going to go through those features to kind of allude to why it is so productive and some of the capabilities it has. You get an idea of the fact that the main course is 5 days long, that it's incredibly rich, that there are a lot of capabilities built into this language, and we can only really lightly touch on most of those. We're going to do a deep dive in certain areas as we have time, but fundamentally use this as a launching pad if you haven't fully explored the capabilities of the language. There's a lot of great documentation out there around it, a lot of publications from MS Press and so on that you'll see linked to around this course, that you can really go in and deep dive into this language.
And I think because it's based on some of the core C syntax, it's a very comfortable language for a lot of developers across a lot of platforms. Even now, most of the key languages are some variant of C syntax. So C# is a very comfortable place to come in. They naturally understand many of the kind of tricks around it that seem confusing. They've learned in other platforms as well. So I think it's very comfortable. We used to call it JUMP. I don't know if that was an official term or not. Java User Migration Path.
Oh, that's
where
right.
C# was a comfortable environment for developers
Exactly.
who knew
So there's a
other
common
languages.
core. So this next slide kind of is interesting to us that have been with the language for a long time, because what it really speaks to a lot is the actual core language was pretty much bait right out of the gate.
Yeah.
That there was a lot of really great core foundational syntax and style and capability in that core language. But it hasn't stood still. As certain trends have taken off within the industry, the language has responded. The team that is responsible for managing it have introduced new capabilities. And a lot of these new capabilities have really been focused around developer productivity.
Always productivity, it seems. It's such a productive language. It really is. It's a comfortable language, but also one that just every time they introduce a new feature, it reduces lines of code that I write.
Yeah.
I love that.
I mean, I can remember back in 2005 when C# 2.0 came out, and with the introduction of generics. Generics was a very big deal for me at that time. I was doing a lot of data access code, a lot of repetitive code was being written that I could have templatized if I had the ability to do so.
Yeah.
Generics introduced that ability, and we'll touch on that a little bit later on.
The other pieces that you see, I mean, it's interesting because you can look at code and see almost the pedigree of the code. You know, you can see I can tell you what year that was probably written in by just
Exactly.
what they're doing. And even now we're at C# 5, but you can still see developers that aren't, they haven't gone into the features of 3.5 or into the features of 4. And so it's interesting to be able to see and kind of evaluate it.
Yeah. Once again, I have to thank Microsoft IT for popping that up over my presentation. Apparently, BitLocker is being changed.
Ah, fantastic.
Awesome.
We don't want it to stay the same. It's all about innovation here, and things can't stand still.
Exactly.
Especially BitLocker.
Exactly.
All right.
Okay, so let's talk a little bit about how C# implements some of those key object-oriented capabilities. So C# and encapsulation. So give me a recap. What's encapsulation?
Well, encapsulation, to go back to the analogy, is the wall around your code that doesn't let people see into it. But we do have these windows and doors. And so as sake of analogies, that allows us to introduce this concept of public and private. And so inside the wall, I have everything that's private, and then I want to keep private, either not to expose the logic to other developers or other systems, or because it's so complex, I don't want to confuse or make the implementation so that it's wrong. So I have this idea of private inside the box, and then I have these touch points where it's public, and I allow them to interact with my code. That's encapsulation.
Perfect. So C# supports encapsulation by leveraging the unified type system, which is this type system that the Common Language Runtime provides for us. So that is a common way of sharing data. and exposing data out. It leverages things called classes and interfaces, and we'll get into those definitions a little bit more. A lot of more classic object-oriented environments only support the concept of classes. C# leverages interfaces, and we'll talk a little bit about why we need interfaces in C# later.
Well, I want to drill in just for a second to unified type system. A unified type, that is something special to the .NET runtime, and I guess at its core, what has happened is we've identified all of the repetitive types, all of the universal types, and brought them down into the runtime so that you don't have to recreate those up inside your own code, right? And so from app to app to app to app, you start having a commonality of all these types.
Well, and also it's language to language to language to language. You can actually share those. If you expose out a public property and an assembly written in, say, C#, you can consume that on the Metro side of the house or the Windows App Store side of the house. You can consume that in JavaScript. Maybe foreshadowing.
We'll have to talk about that later. Yeah, exactly. All right, on into inheritance, because inheritance is a tricky topic.
If you say so.
Oh, it's tricky. All right. So, genetic inheritance is the best analogy, where you have the big nose just like your dad. I'm not really talking about you specifically. That was the arbitrary. That's right. Can we not do the profile shot?
Exactly. You have to zoom back out. Okay. So C# and inheritance. As we mentioned, we have classes in C# and they model the overall template of a type. So they really help define exactly what a type is. In C# there is a constraint, and the constraint is that a class may only inherit from a single base class. There may be a chain of classes that get inherited, but each class can only inherit from a single base class.
That's important, because I think it comes up a lot where developers have implementation in more than one class. They want to inherit from more than one class, but that's not the way it works. The chaining is completely linear. 1, 1, 1, 1. A lot back to the way you are with your dad, my grandfather. I only have one dad when it all boils down to it.
Yep, one certainly hopes so.
I think.
So, and the reason that's key is there are many languages out there that actually implement multiple inheritance through classes. And there was a key decision point made during the C# language development to only support a single base class, and that came down to how C# implements polymorphism in terms of how a class can be represented as any of its inherited classes. Is it allowed the compiler to make a very reasoned and rational decision that was always going to be consistent about what was inherited and where it was inherited from, so that when you did casting, and we'll touch on casting a lot more later, you always knew exactly which implementation you were dealing with.
Yeah, if you had a zillion parents and they had features that overlapped, how would you ever be able to implement that in a logical way?
Exactly.
Yeah, it really cleans it up.
Exactly, makes it much simpler. So, how we were able then to support some form of multiple inheritance is we were able to leverage something called interfaces, and we'll go into interfaces in a little while, but fundamentally an interface is a promise. It talks about this is the behavior that any class that implements this interface will provide. You can use it to mark it as being something that is of this interface, and to also implement those behaviors.
Certainly understanding what interface an object implements allows you to understand it. It's a description of the class or the object, no doubt. But you're right, it is also a contract or a promise that says if it does implement it, or if it does have this interface, it must implement it, and we wouldn't allow it to compile if it didn't.
Exactly.
Beautiful.
So finally, C# and polymorphism. Wonderful word.
Polymorphism.
So here we start getting into things where the language, sometimes it's tough for us to express this concept in a way that makes sense, and so we'll be demoing this in a more visual way a little bit later. But basically a class can be used as its own type. Say for example we have a person class. We might inherit from a person an evangelist class, and we might inherit from a person a developer class. Sorry, I thought I was
trying to read your mind.
Exactly. You were trying to foreshadow there, wasn't it? Yeah. Cut to slides.
Bam.
Shampoo. So basically, we can then refer to a developer class as its base class.
Yeah.
Or we can turn around and say, I want to interact with this developer class as its base, which is the person class.
Yeah.
And so that is polymorphism, and we use an implementation called casting to move one type to its inherited type and back, and we'll touch on this scenario a lot more. We can also turn around and say, if we developed a interface called C# Coder, then both a developer and an evangelist could implement that interface, and we could then refer to those instances as C# coders as well.
That's interesting, because now I can cast you into 3 types. I can have you as developer. I could have you as C# coder, the interface.
Yep.
And that's easy enough. We share that, but we also both inherit from the same parent person. Right? So now I could cast you into all 3, and that's polymorphism. Is that you suddenly in my code can become any of those 3 at any time?
Yes, and that gives us a lot of flexibility, and we'll touch on that a lot more. There's another form of polymorphism that C# enables, and that is around methods. So a method is a function, it's a encapsulated piece of functionality that an object can perform.
Yeah.
We can define at a base level that a specific implementation, we mentioned toString before, a specific implementation of string could be overridden by a descendant, a subclass or a derived class.
Yeah.
So to use this scenario, say the toString method on person just says person, but we want a evangelist to turn around and say, oh yeah, shampoo, when we say toString.
Optimism,
exactly.
Optimism, inspiration. That's what an evangelist says.
Okay. So in the definition of the evangelist, we can override the toString method and ensure that it says exactly what we want it to say. When we cast that evangelist back to its base person, it will continue to say the evangelist implementation of toString rather than the base implementation of toString.
Now this is confusing, I think, a little bit, because as I cast a developer back to a person, I would expect for it to act like a person, not a developer. So casting doesn't change it back to a person then, Darren?
It depends on how these methods are implemented, and again, we'll go into that because it is a complex scenario. You're absolutely right, and we'll show how you override a method impacts on how it rolls back up the types. But if you have basically a virtual method that you override in a derived class, that implementation follows it back up the chain.
So fundamentally, a developer can be cast to a person, to an iDeveloper or whatever, but it's still a developer. It's always a developer. It never loses what it really is. Now we can just interact with it differently. But developers also have, but now back to a real developer. A C# developer has the control to say, as you cast it around, what is it going to act like? What is it, like, if it goes back to person, is it going to use that base one? The developer can choose that.
Exactly.
Yeah.
Exactly. And as I said, we'll get into that in more detail and show you in code. So we mentioned a number of times that C# supports developer productivity.
Yeah.
And we showed that great graph of all the new features and capabilities that were introduced. So I can't emphasize enough just how rich this language has evolved into in terms of the scenarios and so on, and its focus is helping a developer solve complex tasks without the language and the tooling getting in the way.
Yeah.
There's some languages that you may have used in the past that it's just like, I have a concept in my head, but I just cannot work out how to express it elegantly and effectively within this language. I find C# to be very, very useful in that environment.
Yeah. And I mean, obviously, C# is enabled by Visual Studio, right? Visual Studio and the tooling around it, other add-ons you can have, like ReSharper that you might install. I mean, there are all kinds of productivity gains that you can get from that as well. But truly, it's the language. And when you look at that map of time and you see the things that were introduced, the reality is C# has not changed that much over time. All it's done is increase productivity, and it is a beautiful language. And what's interesting is developers who use it, they're in love with it. Not only because of its elegance, not only because of how it's very logical, there's not a lot of compromise inside of it, but also this productivity piece around it is very important. Now there are some key things. What are some examples of productivity inside C#?
So I think one of the things that's most useful, and I use all the time, is the var shorthand.
Yeah, me too.
So
that means variant?
Absolutely does. Basically, when we're defining variables, prior to the introduction of var, we would always need to specify the type. So if we were using an integer, it would be int, variable name equals, and then a value. And as you start creating your own custom complex types, you typically have these longer and longer type names that you would be expressing in there.
You'd have to scroll to see it.
Exactly, and it would become longer and longer. The reason for having that is that C# is inherently strongly typed, which at its foundation means that you have to declare what type an object is before you start interacting with it, and it will always be constrained to be of that type or a base of that type throughout its lifetime.
Yep.
So it seemed very natural in the initial versions of the language to always be specifying that type.
And as an aside, this is different than languages like, let's say, JavaScript. JavaScript also has var.
Absolutely.
It does not mean the same thing.
It definitely does not.
Yeah.
Because in effect, you can place any value at any time into a JavaScript variable, and it will automatically become of that type.
And you can change the type constantly. You never know really what you have until you do an evaluation of it.
Exactly, and the reality is that environment depends upon the developer's discipline rather than placing constraints within the compiler.
Now, one of my favorite productivity pieces is LINQ. That's the integrated query language, and it is beautiful. LINQ allows me to save so much code. I can interact with different collections or enumerables and do all kinds of operations against it that I would have had to have hand-coded otherwise. And now, because of LINQ being integrated with it, I can do all kinds of things. Even one of my favorite is distinct. In order to find all the distinct members in the list based on some sort of criteria is a one-line operation now, where usually you would have a loop and some if statements, and you'd have variables or some sort of members that are keeping track of what is and what isn't. It's actually excellent. It
is excellent. And one of the key things that I find interesting is, imagine how hard it would have been to use LINQ if we didn't have var. For the return types.
Yeah, you'd always have to know exactly whatever's, yes, exactly.
Because LINQ allows us to project into results that implement specific interfaces so we can iterate through them. But with the advantage of var, we, the developer, don't have to know explicitly exactly what type of enumerable.
Sometimes those types that are returned are just freaking long. I mean, if I got paid by the letter, then that'd be fine, but that's a lot of typing and more likely to get wrong than right.
Exactly. And then lambdas was also introduced at the same time.
Yeah, lambdas are a tricky thing. A lot of developers look at lambdas and that makes them really nervous. I can understand why it does. It would make me nervous. It would make me want to avoid them when I first see them. But once you understand them, there's a lot of power. There's a lot of opportunity to create predicates inside a lambda. We'll spend some more time on it, but a lambda in general is a way for me to express a predicate in a small, tiny little syntax. It's very nice.
Yeah, I mean, basically it is a method that we can define inline and pass around as if it was a variable state.
Now, the C# syntax, generally speaking, is pretty clean. I mean, especially if you know C, but even if you don't, it's pretty clean. The syntax, for example, if you were going to build a class, like let's say lion, right? The lion class is a clean piece. You just define it. You can define whether or not it's public. You can find its name and then go into its members. Generally speaking, those kind of identifiers and pieces are very simplistic, right? You want to make it so that it identifies itself, but it's also at the discretion of the developer. If you have a naming convention, we don't say classes have to be named like this. We don't say methods have to be named like this. We don't say.
Can we show the slide, please?
And generally speaking, it's very readable, right? I mean, one of the things, I was a Visual Basic developer for quite a long time, and I loved Visual Basic. You could read it out loud practically. But the reality is, C# is the same way. It's very clean and elegant and very discoverable by developers.
Absolutely, and as you mentioned, we have the identifiers and the keywords, and as we can see in this example here, the identifiers are the names, so we can see lion, sound, make sound, write line, and so on. And the keywords, they're actually colored quite nicely for us right now in the demo. So public, class, string, get, set, void, and so on.
And this is the simplest of the simple. We could make it very elaborate and say go to code decoration, and we can include attributes on some of those so that we can make them do even more. We can pass instructions to the compiler. We can tell other developers that are accessing and kind of indicate to them how they're supposed to use it. So that sort of decoration on the code is also very rich. We can go very simple, we can go very elaborate, and it's sort of up to the implementer to decide how they're going and what they're going to include.
So wait a minute, you just said that C# is really readable and easy to understand. So does it really need comments?
No, it really doesn't. I think developers just, their code is self-documenting, right? I think we all have that. Of course it does. Of course it does. And there's a lot of different ways to comment. I think that's worth at least pointing out. You can do inline comments, right? // this is what I'm doing.
Yep.
But you can also do very elaborate. If you need multi-line, you can do that /* and begin an entire paragraph description that nobody will read.
Exactly. War and Peace. Or if you actually want it so it could be externally consumed, rather than doing that big block paragraph inside that style of comment, you could actually use the XML documentation syntax, which will allow us to actually extract that information out as a separate XML file, and then we can use some tools such as Sandcastle, which used to be a Microsoft project, but I believe now has been picked up on Coplex and branched out, and this will replace, those of you who have been around a while may recall NDoc was a documentation production tool. We'll actually create standalone documentation that can be browsed very similar to what you see on MSDN, for example, to document your APIs so you can share across your team and perhaps if you're producing a public API out to public consumers.
When we were talking about VAR, one of the most valuable pieces of VAR as well is the ability to do anonymous types. And I know we'll talk quite a bit more about this, but anonymous types allow me, the developer, to not have a full definition of a type. And sometimes that's very important because I need a type or a class that I'm interacting with, and I only interact with it for 2 lines. And so why would I go create a class, the full definition, and everything else, when really I just need to hold a few variables and pass them along and maybe put them in a list and then pass them along, and then I'll just destroy it, right? We could say it's a little bit of developer laziness sometimes, right? Not wanting to do that. In the past, prior to anonymous types, we had to go do that. And so now we can just quickly say this is an anonymous type, and the anonymous type is important because it allows us to, especially with LINQ and using VAR, to be able to interact with complex types very quickly. But the compiler on the back end is actually defining that for us. Where we were being sort of lazy, the compiler on the back end is actually implementing that class.
Absolutely.
And there are some downsides to them too, right? I mean, one of the downsides is they're not portable.
Exactly. They're defined within that scope, and so we can't share them. And because they're not one of the foundational types, they also can't be shared external to our assemblies and so on.
So they're really, really, really useful. But they're also useful only inside a scope.
Yeah, they're a great shorthand.
Yeah.
If you need to reuse the information and you need to share it around, then that's a classic scenario when you need to define your own class for sharing it, or maybe a struct.
Or maybe a struct, right.
Yep. Okay, so another great productivity capability of the language is extension methods.
Yeah, awesome. Terrifying are extension methods. They're almost like the Jedi Force. This is not the method you're looking for.
Okay.
It really is, right? Here I am. You give me an object, let's say. You've sealed it, and it's completely encapsulated.
I've created the string class in the .NET framework.
Right. Wow, that'd be quite a...
That would be quite a...
That's a resume bullet right
exactly.
there. I created the string class. And
if only were true.
What's funny is string.toDog doesn't exist, right? There's no method that says toDog.
It's strange how that is. Why did they not put that in?
It is funny, but if I wanted a .toDog, right, I could totally create that method as an extension method, and then it attaches to that object for me.
But wait, I'm paranoid. I've turned around and marked my string class so it can't be extended. How do you do that?
With an extension method.
Okay.
Very powerful syntax that allows me to basically write a method, a static method, inside a static class, and then reference back to the type that I want to extend. From that point forward, every time I use a string class, I hit dot, there's that static method that I defined. That extension methods, they are sort of scary, right? Because it seems like you're extending an object that shouldn't be extended. Mm-hmm. But at the same time, it doesn't allow you to manipulate the code that's private and inside.
Yeah, so it doesn't break encapsulation.
It does not break encapsulation.
That's awesome. That's great to know.
Now, there are other features that are pretty cool inside C#. One of them is dynamics. This is new, right? It hasn't been around forever. A lot of developers don't use it. Some developers potentially use it too much. Well, generally, what is it?
So basically, C# is a strongly typed environment, which means that you declare the type. This means that everything that's available to that type is understood. So you know that what properties it has, what methods it has, And those are all checked at compile time and dynamically exposed via IntelliSense.
Yeah, so we say it's strongly typed. The strong arm in that is the compiler.
Yes.
And the compiler says, this is the type, this is what it does, and nothing else.
Yep, if you type in a method that doesn't exist, then you get a red squiggly underneath that says, hey, this doesn't exist. If you try and compile, you get a compilation failure. So you never even get to run your code.
This is a warm fuzzy, too, because of the security around it. And then Dynamics come along, and they allow us to shut down that security.
Yeah, so basically what we do with the dynamic keyword is mark a type and tell the compiler, ignore strong typing for this type. Do not enforce any rules around what interaction we do.
Right.
That's scary, but it's also very powerful, and it's also very necessary when you're interacting.
Give me a use
things.
case. So, in fact, let me give you a use case. Let's pretend I'm interacting with some sort of external system, and it doesn't use that shared type system that we were talking about before.
Such as Microsoft Word.
Such as Microsoft Word, or some COM-based system that I'm interacting with, passes it back. Now the compiler will only, it still is treating it like a strong type, right? And I know there's a method there, but it's not exposed through any metadata that I can read it at compile time. So now I need to say .2dog on this weird COM object that's out there. I'm going to get a failure. So I have to use the dynamic keyword to say, ignore the strong typing of this. Let me do whatever I want to, and at runtime you'll see it really works.
Exactly, and I mean that's the key there at runtime. So the methods that you're specifying are evaluated at runtime, and if they don't exist, then you'll get an exception thrown. And we can then manage that within our application and deal with that. I mean, that sounds like it would be very powerful, though. Why don't we use it all the time?
Well, I'll tell you, it's because it's so dangerous, right? I mean, the reality is we spoke for a long time about the value of strong typing inside the managed language, inside the managed runtime. And that allowed us to say we trust our code, the user can trust our code, we have security around our code. Dynamics turns off all the strong typing. Now, so it does allow your code that may not build, could build if you would go through and mark everything as dynamic, but it may not run.
Absolutely.
Right, and so that's the overuse, right? The overuse is, I can't figure out how to do this, I'll mark it as dynamic. That's great for the developer, it runs on your machine, but it may never run again.
Yep.
Yeah, it's very dangerous.
Okay, so we've kind of done a whistle-stop tour through a number of the key capabilities of the environment. But what we thought we would do is we couldn't go spend an entire hour without doing a quick dash into Visual Studio and showing the creation of a quick little application just to demonstrate some key
Let me pull up Visual Studio and just show a quick console app, and you can kind of walk me through some of the pieces that we'll see. So, when I pull up Visual Studio, I have a whole set of options inside C#. I'm just going to pick under Windows. I'm going to pick console app. Has to be the simplest of all the apps that you can write. Right? It's totally tiny scaffolding that you would actually...
This is where I learned most of C#, is just working and playing around with console applications, using the concepts.
Let me do it in a new instance here and just pop this over.
Is that a new instance?
A new instance, right. It's because it's Windows.
Oh, that's special.
All right, so I've loaded it. When I look at the console layout here, I don't have very much. I've just got a few properties here, and it's got a little. It kind of jumps a little, so you can look at it. I'm not quite sure what's going on there, but it's exciting.
I think whatever you're doing there, stop.
I can't. All right, I stopped it. Nonetheless, over there in the Solution Explorer, I've only got really Program CS. That's all there is. That's why it's so simple to do.
Yep.
I see a lot of code at the top already kind of baked in there. Using system, using link. What's a using?
So basically, using is allowing you to use a shorthand to reference types that are stored in what's called namespaces. So using system says by default any types that are declared within the external library system will be available to you as you start to type.
And later we'll talk about including other assemblies and how to do that.
And I just noticed another overload of type there. So type as in typing.
It just goes.
It just goes.
So the usings aren't required. They're just meant to make productivity here. I could type system.collections.generic. Whatever is inside it.
Absolutely.
This is meant to make it easier for me. And sometimes I will have to do that still, right? There will be a conflict in name.
So that gets to namespaces. So as we see here, we have a namespace declaration called console application. As you say, you and I might be writing completely different applications, and we might create the same class. Let's say we create a class called class 1.
And if our different applications suddenly meet each other.
Suddenly meet each other.
Class
and we're in
1
the same...
is a confusion, right?
Exactly.
Two guys named Bob. 2 words named type.
Shut the hell up. And the compiler will be confused. It will turn around and say, there's an ambiguous class declaration here. I cannot resolve nor honor my commitment to making sure that this is strongly typed.
Yeah.
So we will then have to fully qualify that type name with Jerry's assembly or Darren's assembly dot.
It's bad enough you've confused the developer. As soon as you confuse the compiler, you're in serious trouble.
And it will punish you by not compiling.
That's right. That's right. All right, so now I see we go right into a class inside our namespace,
Yep.
and we could go from there. Now, namespaces, of course, can stretch across many different files, many different projects, actually.
Exactly. So, you know, namespaces are generally used to group similar functionality into a common root namespace, so it's easy to find those things. Many companies would use syntax something like company name dot application dot functional area and so on to break up namespaces into chunks.
There's really no guide around namespace, or no restriction around it. If you need a namespace to say Bob dot keep going, right? Whatever it is you want, that's perfect. A lot of namespaces start with company name, maybe application name, things like that.
Yep.
And it's really meant to guide the developer more than anything else. Okay, so let's look back, right? We've been talking about some of the high-level pieces. We'll go more into console apps here soon. Now, at the highest level, we were talking about object-oriented programming and sort of how that is the way modern development is done, object orientation.
Yep.
And how we have safety now through managed languages. We have safety now through a managed runtime that enables those languages, and how C# implements the Microsoft implementation of that managed runtime for developers who understand the C syntax already, but also for developers who just want to be part of the trend. I mean, the reality is, I would say, I don't know the number, but it's a big percentage of applications that are C# and none of the others. You were right, there are a lot of .NET languages out there. C# is head and shoulders above the rest as far as popularity, right? Functionally, they're
certainly this side of the camera.
Especially right here, right? We're really into it. And yeah, I mean, we spent our careers mastering it, and so we're definitely into it, but that doesn't mean the other languages don't have the same functionality, because they end up using the same framework and using the same runtime. And then we talked a little bit about those core pieces and how productivity inside C# is enabled through things like var, things like link, things like lambda, things like extension methods, all of these pieces which are just amazing, right? They can take a block of code that is 100 lines and turn it into a block of code that is now 10 lines, right? And the fewer code lines that you have, the more maintainable it is. The more maintainable it is, also the less likelihood of bugs, which is really important. And also kind of the more discoverable it is as well, because even though we all are building these applications from scratch, hopefully someday we hand these off to maintenance developers, and those maintenance developers need to be able to look at our code and not cross their eyes because there's a million lines that they don't understand. So all of this productivity builds fast, but it also has dividends in the long run as well. A lot of power there. Darren, I'm looking forward to the whole day. There's so many pieces that we get to kind of dive into and talk to. Let's take a break right now, if that's all right with you.
I think it's great.
We'll go get some coffee. I don't drink coffee. I'm going to get some soda, and we'll see everybody in 10 minutes.